Welcome back. Hello everyone, this is Sharda from GoEduHub Technologies and I would like to welcome you all for continuation of this session's classes. Okay, so today's class agenda is what are the NumPy arrays. We are going to study very important data science libraries. One of them is NumPy. What are the NumPy arrays? Then where we can use the NumPy arrays, differences between NumPy array and list, why we prefer the NumPy arrays, and different operations in the NumPy array, how to perform different operations in the NumPy array, and then we will go towards the NumPy special functions, and after that, when time remaining, I'll start the Pandas. Okay, so we will do the lots of things, lots of practical things in the NumPy arrays. So till today we have seen the some basics of the Python, because basics of the Python is very necessary for going ahead towards the data science and machine learning. Today I am going to start the data science library, that is the NumPy, and this is the base library for the data science. If you know the concepts about the NumPy, then you can easily do the calculations on the numerical data, and it have very good functions. We can use directly those functions and we can perform large computational calculations. Okay? Yeah, I'll share all these things. Okay? So, right now I'm starting to all the practicals about the NumPy. Don't worry, I'm not taking the theoretical part. I'll just tell you the concepts only. Okay, first of all, you should know the concepts, and after that we will start towards the implementation. Basically, I'll start in the Google Colab. Little bit idea I'll give you in this whiteboard only. Okay, so first thing comes to mind is why NumPy and what is the NumPy, why we need the NumPy, where we are having already list. Okay, so basically NumPy, if I'll define the NumPy in the single line, I can say what are the NumPy. It is a numerical Python. Okay, let me scroll down. Okay, it is numerical Python, and this is a package inside the Python. We can say a library inside the Python already exists. We don't need to create. Okay, library inside Python. And generally we use this for the scientific computations. You can say for scientific computing. Okay, basically it contains n-dimensional array objects. Whatever we are working, a single element inside this NumPy is a array object. Okay, so basically this is a tool, and we can communicate, we can integrate this tool with the C, C++, already existing languages. Guys, my voice is clear? I've forgotten to ask you. Everything is clear? Okay, so basically n-dimensional array objects. Okay, let me go ahead. And we can integrate we can do the linear algebra, like linear algebra calculation we can do in the NumPy array. If you want to do the big calculations like simple calculation, I'll take the matrix multiplication. You are having two matrices A and B. You want to multiply each element in these two matrices, if you do with the help of the list, it will take lots of time and space consuming. But if I'll do these things with the NumPy array, it will automatically work over the matrices, or you can say arrays. Okay. So linear algebra calculations we can create some random numbers, and we can do the like multi-dimensional array operations easily. It also have good documentation. You can go to the numpy.org. NumPy documentation. Okay. And this is the official website of the NumPy, and here you can see the good documentation. If I'll go towards the user guide, manual, what is NumPy? Okay, here you can see these are the things. NumPy is fundamental package for scientific computing. I'm showing because this is the official documentation. Okay, so you can go through this also after the class, and you can see from our website also, and main concept I'll tell you how to do the practical in the NumPy. Okay, so let's do the practical things here. I'll create new notebook. And it's a title I'll say yesterday also, yesterday's notebook also I forgotten, 26052021. Okay, and here I'll start. First thing, how to install NumPy. Okay, when you are going to use a certain package, you should first install that package. So first thing is how to install the NumPy. You don't need to do much in this. You just write the simple command like pip install NumPy. If you are using Anaconda, you can write the conda install NumPy, and you can run this line. It will show you either the NumPy is already existing, requirement is already satisfied, otherwise it will install the NumPy. You can install this with the help of Anaconda prompt also, and if you are using PyCharm, so there is some options to install the packages. You will go to the particular place and then type this command. Either you can use the CMD also. Okay, so command prompt, you can open the command prompt and then you can install pip install NumPy. And if I'm using the Google Colab, there is already NumPy is installed. I don't need to install it. So this is the installation part, how to install the NumPy. This is very simple. Okay, after installing, how to use the NumPy. Okay, so if you already installed the NumPy, you can import the package. Okay, so import NumPy as NP. Okay, as NP I'm giving a small name. Further, its functions I'm accessing with the help of NP dot. Whatever the function I'm using from NumPy, I'll access with the help of this object NP. Otherwise, if I'm not write as NP, I can use directly NumPy dot. Every time I have to write NumPy dot, but I'm using here NP, so as NP. Further, I'll denote this NumPy with NP. Okay, so simply I can import this and a single one-dimensional array. How to create a one-dimensional array in NumPy. Okay, so create 1D array. Okay, I'm not writing again and again comments. Certain basic comments I'm writing here only. Creating 1D array, for the 1D array, I simply use a equals to np, and there is a function called array, np.array. And np.array, and inside the braces, I need to put the list, values in a list like this. 1, 2, 3. And after this, I'll print a, okay, and then I'll check the data type of a also, okay. Okay guys, np.array, here I have declared the array. You can see the a value is 1, 2, 3. It is just like the list, okay. But if you check the type of a, then you can see here numpy.ndr. Okay, numpy.ndr. So this is like this, we can create the simple arrays in the NumPy. Okay, I have created one dimensional array, nothing else. ND is n dimensional array. Basically NumPy represent n dimension. We are having n dimensional array. This is the basic array we have created, that is the one dimensional array, and then it is n dimensional array. We can create n dimensional array. Yeah, we are checking the website. There are some server issues, so don't worry about all these things. Just focus in the class. Okay guys, this is the simple NumPy array, how to create the NumPy array. Now we will come to the how to create the multi-dimensional array. This is one dimensional array I have created. I want to create a two-dimensional array, or you can say multi-dimensional array. Then I can write like this: a equals to np.array, and inside the braces square bracket. Okay, and then inside the square bracket I need to put the multiple arrays. It's giving the documentation. Okay, here I'll put one dimensional array 1, 2, 3, and then comma separated multiple one dimensional arrays, comma one more one dimensional array like 10, 20, 30. Okay, and now I can run this block, and you can see here this is 2D array, it having 2 rows and 3 columns. If you print a, okay, a is an array 1, 2, 3, 10, 20, 30. So 2D array is collection of 1D array. Okay, so you can create the 2D array like this. Okay guys, clear till now? How to create the array? Simple array I have created. Okay, one dimensional array I have created, and then I have created 2-dimensional array. So this is, and you can create like array with the zeros. Like I just want to create an array with value zeros, and I can give the size also. Okay, so here I can write like this: np.zeros. Okay, and inside the braces I can specify its a size 2, 3. This would be an array of size 2 rows and 3 columns and having all the 0 values. So I'm creating an array. Here I'm creating an array simple with the help of list. So np.array, and inside the square bracket I'm putting the multiple list. Multiple list means I'm creating 2D array. I'm creating a 2D array with the size of 2 rows, 3 columns, and that will have the value 0. So zeros is a function inside the NumPy array. Okay. Similarly, like I can create zeros will create an array filled with the 0 values. Or here this 2, 3 is a specified shape. You can change the shape according to your requirement. Like I want a 2 rows, 3 column array. I want 5 rows, 3 column array. I can change accordingly. Okay. And it's a data type also I can check. So just wait, I'll come to the data type. And next thing is how to create an array of regular interval values. Like I just want to create an array with regularly incrementing values. Like np.arange. There is a function called arange, and inside the arange I'm putting 10. It means it will create an array of regular interval difference of 1 and will have the 10 values will started from 0. Okay. Arange, I can change the arange. Like here I have given only one value. One value means this is the total 10 values I want. Okay. I can change this, its parameters, like np.arange. Okay. And inside this I can put like start value 2 and 3, and I can say 0.1. Let me run this. So if I'm putting here the 3 values, it means first is the start value and this second parameter is stop value. This is similar to the range function. Okay, arange is similar to range function. Start value is 2, stop value is 3, and difference is 0.1. Here I have provided only the stop value, so by default it will take the start value 0 and difference of 1. Okay, here I have provided 3 values, so it will start from 2 and will go till the 3 not included, and difference of 2.1. So 2, 2.1, 2.2, 2.3 like this. I can put like this also, np.arange 2, 10. 2 parameters. Then what it will do, start from 2 and will go there 10 and take a difference of 1. So 2, 3, 4, 5, 6, 7, 8, 9. It is similar to the range function. Okay. So this is the arange function to creating the values, regularly incrementing values. Similarly, we have one more function to creating the arrays, that is the linspace. Okay. So I'll show you how linspace working. np.linspace. Okay. And inside this, linspace basically create the arrays with a specified number of elements and spaced equally between the specified beginning and end values. Let me write here 1, 4, 6. I'll show you just np.linspace 1, 4, 6, and let me run this. You can see here it will start from 1 and how much element we want. It will start from 1, it will go till the 4, and we want the 6 element. Here we want the 6 element. Here we specify number of elements how much element we want to generate, and all the element would be equally spaced. And this first parameter is beginning and the second parameter is ending. So in between 1 to 4 we want to generate 6 values that would be the equally spaced. Okay, so linspace basically it guarantees the number of elements and starting and end point. Got it? Yeah, first understand NumPy. We will see that what is the array also. Simple array, you can see. Simple array is homogeneous elements in the continuous memory. Okay. So this is the linspace function, how to creating the arrays with the help of NumPy. There are lots of functions. We have seen the array function, then we have seen zeros, and similarly we have ones function, we have arrange function, we have linspace function, and we have eyes function. There are the lots of functions. Okay. We also have indices function, like np dot indices. Okay, this will create a set of arrays. Okay, one per dimension with each representing variation in that dimension. Let me show you. Indices, here I'm putting 3, 3. You can see the output. Okay, here we are creating 3, 3, 3 rows and 3 columns. Okay, you can change this by 2 by 2 also. You can see the difference. 2 by 2 means 2 rows and 2 columns. Okay. One row wise and one column wise. Yeah, like here 0, 0 index row wise and here 0, 0 index column wise. So both the way it will give you. Like if you write 3, 3, it will give you indexes in row wise, okay, and then indexes in column wise. 0, 0, 0, 1, 1, 1, 2, 2, 2. So this is the indices, how to create the indices. Now we will see the different data types. And some more functions I'm leaving, like I, and there are the lots of functions. Nobody can remember all those functions, but there are lots of functions to creating an array. Okay. Now I'll show you the data type. Like data type, a array having like A equals to np dot array, and inside this I'm putting certain values like 1, 2, 3. A Google Colab provides you documentation always. Like help, it's not called the documentation. Print A. Okay. This is the simple array, and then if I'll print A dot D type. Okay, you can find the data type of the elements that are stored inside the array. So if you want to know the data type of a particular element, you can use dtype function. This function will print the data type along with the size. So here the A.D type, data inside this array is int 64. Okay. Clear? So let me go ahead. It have certain features, like it have certain properties, NumPy array. And first of all, I'll tell you the difference between the NumPy array and list. What is the difference between NumPy array and list is similar. You can see we have studied the list, and today we are studying the NumPy array. So what is the difference between list and NumPy array? List versus NumPy array. Okay, major points I'll tell you what is the difference between list and NumPy array. Okay, You can say first thing, very important, you can say list is like NumPy array is taking less memory. I'm writing about the NumPy. Okay, less memory compared to the list. And one more thing I can say, we will prove these points, don't worry. NumPy array is fast, and one more point I can say, it is more convenient. Main 3 points I'm telling you. Okay, like NumPy array always occupies the less memory as compared to the list. And it is pretty fast compared to the list. And we can easily work with the numerical data. Okay, so I'll show you the practical thing, how it is taking the less memory, how it is fast. We will see one example with the help of list and NumPy array both. And you will yourself figure out the difference. Okay, so let's take an example. Like first I'll taking a NumPy array. So import NumPy HNP. If you have already written this line, no need to write again and again. Okay, and then first thing I'll show you how like size memory, how much memory NumPy array takes and how much memory the similar values. Like if you want to create a list of what happened. Okay, if I'll write something like this. Okay, so if you want to create a same length of list and same length of array, and then you will see how much memory is allocated to a list and how much memory is allocated to a NumPy array. Okay, so there are some functions to get the size of a particular array and size of a particular data type. Okay, here we will take like a list. I'm generating L, or I can say list. I'll write L equals to range. I'm creating a list of 1000 values. Okay, it will create a list of 1000 values. Okay, and then I'll see how much size they have taken. So for this I need to import the sys module system. This module inside the Python to calculate the size. Okay, so I'll print sys dot get size. There is a function called get size of. Okay, and inside this function I need to pass a particular integer. Like here a equals to, I'm taking 10. This is a simple integer. Okay, and here I'm passing a. So how much size a particular integer is taking in the list? It's taking 28 bytes. Okay, and if I'll multiply this 28 bytes with the complete length of this list, then I'll get the size of this particular list. Size of particular, this is size of a integer data type. Memory allocated to A. Okay, and memory allocated to list L, how I can change? Print, I can write sys dot get size of, okay, get size of A into length of this list. How much elements inside this list? L, length of L, and I can write this. This is 28,000. Okay, and similarly I'll do this thing for the NumPy array also. Okay, so I'll create a NumPy array. So NumPy array, how I can create? A equals to A1 equals to NumPy array. I am creating np dot a range, and here I am putting 1000. Okay, and then print A1 dot size. What is the size of this? 10,000, sorry, 1000. And this size I'll multiply with a function inside the NumPy array. If you want to get the size of a particular element, then there is a function item size. Okay, so I'm multiplying this with the item size into a individual item, how much bytes individual item will take. Item size, A into item size. And now you can see what has A1. It's not A, it's A1. So difference is our NumPy is taking 8000 bytes and our same size list is taking 28,000. Got it, the difference? From this example, you can see the memory allocated by the list is 28,000, whereas the memory allocated by the NumPy array is just 8,000. So you can conclude that there is the major difference between the list and NumPy memory allocation. So we always prefer to use the NumPy. First point, less memory. I cleared this first point, less memory. Okay, and next thing is I will show you how NumPy array is fast. I can write here the comment NumPy array versus list memory allocation. Okay. Next point, I will show you speed. Okay guys, so let me go ahead and will show you how we can check the speed. So for checking the speed, we can use the time module. Inside the Python, we are having the sys module. Similarly, we are having one module called time. So I can use the module time, import time. Okay, and I also have to import sys. Okay, now I'll create two lists, L1 and L2, and then I will do sum of their elements. Like I just want to sum the corresponding elements, sum of two list elements. Like here you can see, I can tell you, one list is L1 list having 10 items, 1, 2, 3, 3 items, okay, simple. L2 list having 10, 20 and 30, and we just want to do the sum. How you will do the sum? 1 summed with 10, 2 summed with 20 and 3 summed with 30. So the output list should be 11, 22 and 33, something like element wise sum. Okay, this thing we will do with the 1000 element list. Okay, two lists, this list having 1000 elements and this list having 1000 elements, and we will do the sum of L1 element wise L1 plus L2. Similar thing we will do with the NumPy array also. In the NumPy array we will take two NumPy array, N1 and N2, having 1000 values and 1000 value, and then we will sum element wise in the NumPy array. Then we will see which one is taking more time. Okay, which one is taking more time? Memory size is nothing. Here we are using two functions. From the sys get size of, we are using get size of will give you the size of particular data type. So a particular data type, a data we are taking, that will taking the 28 bytes, and we will multiply with the total length of the list. So it will give you the total bytes taken by a list. And similar thing, if you want to take the size of a NumPy array, you can, total size of NumPy array is a dot size, how much element, you can multiply with the 1000 also, but I just want to keep here the variables a dot size, and then a particular item, how much memory, how much bytes taking, a dot item size. So we can multiply both. It will give you the total bytes allocated to a NumPy array, and it will give you total bytes allocated to a list, and you can see a huge difference. Okay, and now see the speed thing. In the speed thing, I'll declare two lists. Okay, so here L1 list, L1 I'm taking range, I'm creating L1. Initially I'll define a variable size. How big? 0 0 0 5 6. I can put the 6 zeros. Okay, and I'll create a list of this size. Okay, this is a list, and I'll create another list L2 range, and here also I can put the size. Okay, and then I'll sum, it's element wise. How to do the sum? You can write the loop. Okay, so first I'll start the timer. Okay, for starting the timer, I'm writing here start equals to time from the time module, time function I'm picking, time dot time. Okay, and then I'll write here like some result would be result equals to, I'm writing a loop. Okay, and inside this is the list comprehension x plus y for x comma y. You can write two loops also. I'm just writing the small code. Okay, L1 comma L2. Okay, so here what will happen, this for loop, in this for loop we are taking two iterators. Like here we are using the zip function. Yesterday I told you the zip function. So inside the zip I'm putting two lists. So it will, inside the x will go the first element from the L1, and inside the y first element from the L2, and we will sum the both elements x plus y, and result would be stored inside this result. Okay, so same thing will happen with the complete list L1 and L2. Okay, after that we will calculate the time. Okay, so what's the time now? We will, current time we will subtract from the start time. From the current time we will subtract start time. Okay, so time dot time, it's a microseconds minus start. Okay, so I'm multiplying with 1000. It's optional. Okay, and this will give you the time taken by the list, 156 microseconds something. Okay, and same thing I'll do with the NumPy array also. So I'll declare two NumPy arrays. Okay, N1. You know how to declare the NumPy array? np.arange, and inside this I'm passing size. Okay, and then n2 equals to np.arange, and here also I'm passing size. Okay, and this part is for list. And now I'll do for the NumPy array. Okay. So same thing I'll do here. First I'll check the start time. I'll pick current time, time function, and then how to sum element wise in the NumPy array is simple. Result 1. I'll take the result 1 equals to this n1 plus n2. Simple way. I can sum. It will sum element wise. I don't need to write the loop here. Okay. And then I'll print here same thing. Okay. Time. Okay. And then minus start time into 1000. Okay. And let me run this code. You will see the difference. In the NumPy array, in the list, it's taking 179 something. And in the NumPy array, it's taking only the 3. You can see the huge difference. So, from this example, you can see the NumPy array is fast. It's faster than the list. That's why when we are doing the big calculations, scientific calculations, we always use the NumPy array. For the data analysis, wherever you are working over the data, okay? Okay? So here we are taking how fast this difference between the list and NumPy array. This is the basic thing you should know. Okay? This is the main topic, guys. Some people are writing, ma'am, move to the main topic. This is the main topic. You are seeing the NumPy, and when you are studying the NumPy and you don't know how to work with the NumPy, then how can you work? How can you work with some projects? So that's why I'm telling all these things. These are the very basic things, and these are very important. In some interviews, people will ask this question: what is the difference between the list and NumPy? Why you are using the NumPy? You are a data science student. You should know the basics about the NumPy. Okay? Loops never fast. Okay? Time also depends on your processor also, but you can see the huge difference. Okay? And third point is convenient. We can do the big calculations easily without writing any loops and anything else in the NumPy. So these 3 points I have proved these 3 points: less memory, fast and convenient. That's why we prefer the NumPy for doing the data operations, for doing the big calculations. Okay? Now we will see some operations in the NumPy, okay? How to do the certain operations in the NumPy. So I'll declare a 2D array here, A equals to some, you can say NumPy operations. So here I'll declare a NumPy array np.array, and then inside this I'm putting a 2D array 1, 2, 3, and then I'm putting something like 10, 20, 30. Okay, this is 2D array. Okay, and then there are the certain things, like first thing is endim. How to use the endim? What is the endim? You can find the dimension of the array. So if I'll write print a.endim, okay, endim will give you the dimension of particular array. Here you can see it is giving you 2. 2 means it is a 2-dimension array. Okay. So how we can find the dimension of array with the help of endim? You can write simply a dot endim. Okay. Similarly, item size, I already told you, you can write like this also, print a dot item size. Okay, and here you can see, you can calculate the byte size of each element, 8 byte. Each element will take the 8 byte in this array that we used previously. And one more thing you can write like this, a dot d type, that is also we have seen data type inside this array in 64. Okay, and similarly we can write like a dot shape, print a dot shape. Okay, shape is 2 rows and 3 columns. We are having 2 rows and 3 columns. How much rows and columns we are having in an array? Similarly, we can write a dot size. Okay, size is total number of elements. You can multiply 2 into 3 is 6. Total number of elements inside this NumPy array is size of this NumPy array. Now come to the important thing, that is the reshape of an array. Reshape. Okay, this is important function we are going to use somewhere in between the machine learning models, or when you are using some data, you need to reshape the data. Okay, reshape is basically when you want to change the number of rows and columns. Okay, like you are having 2 rows, 3 columns, you just want to reshape that to 3 rows, 2 columns. Okay, you are having 2 rows, 3 columns, and you want to do the reverse, 3 rows, 2 columns. So you can convert that. Like our A having 2 rows, 3 columns. Now I just want to reshape this A. Okay, so A dot reshape, and now I can put here 3, 2. 3, 2, what it will do, first 2 elements it will put into the first row, then 3 and 10 in the second row, and then 20 and 30. It will go from left to right. Okay, so you can reshape its elements from, you are having 2 rows, 3 columns, you can convert into the 3 rows, 2 columns, and lots of things we can do in the reshape. Okay, let me show you some more examples, don't worry. Okay guys, and what is left out? Slicing. How to do the slicing in the NumPy array. Okay, slicing is, you just want, basically you want to extract a particular set of elements. A single element you can access from this array like this, A in a 2D array. From a 2D array you just want to just print the A. Okay, this is the my A, and I just want to access 2. Indexing and slicing, I'll tell you. I just want to access 2. Its indexes is from 0, 1, 2, 3 like this. This is 0th row and first row, and 0th column, first column, and second column. So I just want to access 2. Okay, then I can write like this, A of like 0, 0. This will give you the first element. First thing is, this is row, column. And if I'll write like this, A 0, 1. Okay, for 0th row and first column, this is 2. So individual elements I can access like this. But I just want to access a set of elements from the array. I just want to access 2 elements, like 20 and 30 together. Then I can use the slicing. Okay, individual element I can access, but I just want to access 2 elements. Okay, so in the row I can do the slicing, in the column also I can do the slicing. So I can write like this: a of 0 through, okay, and 1. What does it mean? Row will start from 0 and column. After the column I have not written anything. It means it will pick all the rows. And column it is picking only the first column. So you can see 2 and 20. All the row, in the first row, first column is 2. In the second row, first column is 20. So it will give you the 220. Basically what we are doing here, I can show you here by writing the things. Like A equals to, you are having a 2D array. 1, 2, 3, and then you are having 10, 20 and 30. Okay, you just want to access single element, then A of 0, 1. It means this represents to row and this represents to column. I want this thing. So I want all the rows and first column. So for the row I am putting started from 0, end point I am not putting. And for the column I am putting only 1. It means all the rows and first column. I want this thing, 20, 30. Then what I will write? I want first row, okay, and column I want 1 column. So it will, in the first row it will see from first column onwards. So first column and last column. It will give you 20, 30. Okay. Continuous 2 values, 3 values you want to pick in the NumPy array, you can use the slicing. Slicing in rows and columns. Okay. Okay, what do you want? Basically here we are doing the slicing. Like you want to access 2D array, it means here the rows and here the columns. Okay, and you want multiple rows, so you can do the slicing here. In the slicing, start, colon, stop. Same thing you can do in the columns also, start and stop. Okay, you don't write the stop, it means it will go till the end. You don't write the start, it means it will start from 0th. You are not doing slicing, it means it will pick only the first row. Okay, we will see the example also. In this example, you want to pick the first element, then 0th row and 0th column. Okay, you want the second 0th row, first column. Okay, you want all the rows, you want 2 and 20. Then what you want? You want second column. This is second column, 220, and all the rows. So in the rows we have written started from 0, 0 column, and in the column we have written only 1. Okay. I can write A 0 colon 2 comma 1 colon end. You can see this is a sub array. 0 colon 2 means it will include 0th and first row. 2 is not included, and 1 colon, this means it will include first and till the last column. So first and last column. So it will give you 2 rows from both rows, 0 and first row, and column we are picking from first onwards. So you can see here, column we are picking both rows and column we are picking from first onwards. So 2, 3 and 20, 30. Okay? So like this we can do the slicing in the NumPy array. We can access the subset of an array in the NumPy array. You can put a bigger array, like you can take an array like this, np.array, and inside this I'm putting a bigger array. I don't want this. A equals to np.array. Okay, inside the braces, inside the curly braces, 1, 2, 3, 4, 5. Okay, and then comma 10, 20, 30, 40, 50. Now I can run this. And you can see the a dot size. Okay, size of this we are having a dot shape. I am having 2 rows and 5 columns. Now I can see the slicing very nicely. Like here you can see I want only first row and I want 2 columns. 2 column 4. So I want only 2 columns, second and third column from the first row. Second and third column from the first row, that is the 3, 4. Sorry, first row. This is 0th row and this is first row. So 30, 40. Okay? This is the slicing and indexing part, and this is important part. Now I can show you how to get the minimum value in the NumPy array. You can get the minimum value like this, print a.min, okay, and then I can print a.max. There are lots of functions. I try to cover the important functions, min, max, okay, and you can also do the sum of NumPy array elements, a.sum. Okay, a.sum, it will sum all the elements of the NumPy array. Now you can see the GoEdu hub. Okay, and here in the free tutorial you can go to the ML part and this NumPy. Okay, just go through the article. Creating the array we know, accessing the array elements we know, 2 rank array how to create we know, indexing we know, okay, indexing and slicing we know. You can try all these things. Shape, all these things I have told you. And then mathematical operations, okay, so we can declare 2 arrays and then we can do the mathematical operation. That I will tell you now. Okay, mathematical operation is remaining part, and most of the things I have covered. Yeah, sum. The sum is x is 0, and I can write this also. New tab opened. Okay. A.sum. Okay. Here I can write like this. I can pass certain parameters inside this. Like simple sum, it will give you the sum of all elements. I want row-wise sum or column-wise sum. Then x is equals to 0. Let me remove first this. Okay, and you can print E. We'll clear more about this. A is my this array. Okay, x is equals to 0 means we are summing column wise. X is 0 means sum column wise, means for first and second both the rows we will sum the first column. So 10 plus 1 11, 20 plus 2 22, 30 plus 3 33. If you want like row wise sum, first row sum, second row sum, then in place of 0 you have to put here 1. Okay, in place of 0 you have to put 1. In this case, first row sum, total first row sum, 1 plus 2 plus 3 plus 4 plus 5 is 15. And then 10 plus 20 plus 30, 40, 50 equals to 150. So row wise sum you can do, column wise sum you can do, and row wise sum you can do. Okay? Yeah, I'll come to the reshape again. Okay, don't worry. So some function is clear, I think. Now one part is remaining that I'll see. That is the some mathematical operations, and then I'll see tell you some more examples over the reshape. Array in mathematical operations. This is also important part. After that, we have covered the NumPy things. Mathematical operations. Okay. In the mathematical operations, I'll create 2 arrays. Somebody is asking some part again. I don't need to repeat it again. You after the class, you please go through the tutorial also. This sum, we will sum the elements row wise or column wise. If you want to sum of all the elements, then just put the sum simple. If you want sum of first row elements and second row wise sum, then you can put the x is equals to 1. If you want column wise sum, first column sums, all first column sum, all second column sum, all third column sum, then you can put x is equals to 0. Okay. Mathematical operations, like I just need to put 2 arrays. Okay, I need to declare 2 arrays. And then I'll do the mathematical operations. Let me copy this code. I don't want to write again and again the things. Okay, here you can see I have declared one NumPy array x equals to np.array 2D array. It having 2 rows, 2 column, 1, 2 and 3, 4. Similarly, y is np.array 5, 6, 7, 8. If I'll print x, I'll print y. Okay, it will give you the array. I just want to sum element wise. There is some error. Let me check what happened. Okay, braces is missing. Okay, you can see here x is 1, 2, 3, 4 and y is 5, 6, 7, 8. Now x plus y. What we are doing here element wise sum, like 0, 0, element will be summed with the 0, 0 element of y. So first element would be 6. Similarly, second element will be 2. We will sum 2 with the 6. So that would be 8. Index wise, 3 we will add 3 with the 7. So that would be 10. Element wise sum we are doing here. Okay. So for doing this, you can write simply x plus y. Or you can write the add function also. This also give you the same answer. np.add x, y. Both things are the same. Okay, x plus y. Similarly, I can write these things like I just want to do the subtraction, so I can write this print x minus y, okay, and for this sub function I can use print, and inside this x comma y. Similar thing I can do with the multiply also, np dot subtract. There is function is subtract, I don't remember. In place of subtract, let me try the subtract. Yeah, subtract. Okay. Next thing is you can do the multiply also, you can do the divide also, and there are some other functions also available. Let me go to the tutorial. X minus y, x into y, x divided by y. You can write like this. Square root, if you want square root, np dot sqrtx. You can do the square root also. Okay. Some part I have told you. These are the things. Now I'll explain you a reshape function one more time. Okay. I think most of the things I have covered. Okay guys, can you please give me a quick confirmation? Are you getting the things? Like till now, whatever we have covered in the NumPy, can you tell me, are you getting all these things? If you have little bit confusion after the class, you can revise this class and you can go through the tutorial also. If you will do a example by yourself, then you will get the more clear idea about each and everything. Okay. Let me tell you the reshape again. Okay, so just hit the thumbs up button also. I'm seeing 751 people are watching and only 220 likes. Okay, it's clear. Most of the people getting the things. Siddharth, what is the issue with you? Slicing one more time. Slicing is simple. Yes, here. Just remember one rule. In 2D array, first thing represents to the rows and second thing represents to the columns. Rows, comma, columns. And if you want more than one row, then do the slicing in the row. And if you want more than one column, do the slicing in the column. Like if you want only one row, one column, like single element, then you can put simple index 0, 1. If you want two rows, yeah, you want all the rows, only first column of all the rows. So in the row you will do the slicing and column you will put as it is, like first column you want, and in the rows slice operator, colon operator, that is just like the list or a string. We have done the slicing in the list and a string. So here we are doing the slicing in rows and column. First thing represents the rows and second thing represents the columns. Okay. Okay, let me do you the reshape thing again. A equals to, I'm declaring a NumPy array np.arange, okay, and I'm creating a NumPy array of size 6, okay, six elements I'm having, okay. If I'll print this A, you can see continuous 6 values 0, 1, 2, 3, 4, 5. Now this is one dimensional array. Okay, 1D array I have created with the help of arange function numpy 1D array. Now I just want to convert this 1D array into 2D array. Then I can use the reshape function. Okay, so A equals to A dot reshape. Okay, and inside the reshape I'm passing the dimension. Dimension is 3, 2 I'm passing. Means I want 3 rows, 2 columns. Total element should be 6. Here total elements is 6. So multiplication of both dimensions should be 6. It should not exceed from the number of elements. Okay, so 3 rows and 2 columns I want. So now if I'll print A, you can see the new A. New A is, it will first 2 elements, then second 2 elements, third 2 elements. It will create rows. First row of first 2 elements, second row of next 2 elements. Okay, it will create 2 elements, 3 rows. Getting? Inside the reshape, I can write like this, and I can change this function also. Same thing, sometimes we are writing like this also. Let me show you print. This is print A. And same thing, we are writing like this also. np dot, another way. Okay. np dot reshape, you can call this function like this also. And inside this, okay, I'm passing A. Okay, A, and I just want to reshape this A. Like 3, 2, I want 2, 3. Okay, reverse back. And you can see, initially this was one dimensional array. Then I have converted this to 3, 2. This is 3, 2. Then I have converted this A array to 2, 3. I can use this index also, and this is the another way. But here dimension I have changed. I can put 2, 3 means I want 2 rows, 3 columns. So 1D array I have converted into 2D array. Okay, and 2D array I can convert back to 1D array also. Okay, I just want to change this 2D array to 1D array. Okay, let me write this. Reverse back. np dot reshape, okay, and this A is 2D array, my final A is 2D array, A, 6, okay, and let me print this. A, 6 is 0, 1, 2, 3, 4, 5. This is 1D array. So if I am providing here one dimension, it means whatever we are having inside the A is 3, 2. You can print the A also. If you have a little bit confusion, print A. Okay. First you will print A. A is 0, 1, 2, 3, 4, 5. 3, 2 array. And then I have converted this 2D array to 1D array. Total number of elements I should know. Okay. How can I get the total number of elements? I can get total number of elements with the help of the size. A dot size. So I can use A dot size also. So A dot size I know 6. So I can put here A, 6. So I want from 3D array, 2D array to 1D array. Okay. Get it? What is the reshape? I think now this is enough about the reshape. You can use this reshape. There is some other functionality also. We can use the ravel function also. We can do the indexing like reshape like the C. We can do the indexing order like Fortran. These things we can use the ravel function. Okay. Simple this reshape is indexing like the C language. Okay. And inside this we can use the ravel function also. And we are also having the flatten function. Flatten function we can convert like 2D array to into 1D array. Like here you can see print A. Okay. A is 2D array. Okay. And I can flatten this array. Print A dot flatten. Okay. A dot flatten here method. I should put this method. A dot flatten, it will convert to the flatten. You can see this 2D array is converted to the 1D array. Multi-dimensional array, you can do the flattening of multi-dimensional array. Okay. So I think this is enough about the reshape and NumPy. I have tried to cover most of the things about the NumPy. Okay. Next thing is I will give you the little bit introduction about the pandas. Before going ahead towards the pandas, if you have any question regarding the NumPy, you can ask me. Okay, I'm seeing your chat window. So you can ask me about the question in the NumPy. I have tried to cover most of the things in the NumPy. And for the more things, you can visit the NumPy documentation. That is the good thing. NumPy documentation. Because there are the lots of functions, one cannot remember all those functions, and we don't need to remember. We have good documentation. You should have the basic knowledge about the library, how you can use the library. If you know the knowledge about the library, then you can, anytime you can start working with the library. Basic idea how to work with this library, then you can start using any function. Just go to the documentation and you can see lots of things. Min and max function is just getting the minimum value and maximum value from the NumPy array. Okay. Let me just conclude this NumPy array. Like here what we have covered initially, what is the NumPy array, where we use the NumPy array. NumPy array is for the numerical calculation, scientific computing, and these are the numerical Python you can say, and it have lots of features, or you can say lots of functions inside this. Using those functions we directly work with the arrays. Okay, and it is more powerful than the list. It have like it is more fast, it is taking the less memory, it is more convenient to working with the arrays, with the help of NumPy instead of the traditional data type in the Python, that is the list. And then in the NumPy, lots of basic operations. We have seen how to do the addition, multiplication, subtraction, divide, and how to do the sum of, how to do the slicing and indexing, how to access the elements, And if you want to access the random element, one thing I remember I left out, like in the indexing, we access the continuous element, but I want to access 10 or 30. Then what I will do? I just want to access 10. I want 10 and 30 only. Then what I need to do here, like A, here first I'll put row and columns. So A in the row I will put its row index is 1 and its column index is 0, and its row index is 1, its column index is 2. So in the first array I'll put both row index like 1 and 1 comma 1, and then comma, and then we will see the column index, so 0 comma 2. So it will map like this row 1 comma this column, 1 comma 0 is first element, and second is 1 comma 2. Basically this is having all the rows index, this is having all the column index. So row indexes, whatever the element you want, put its row indexes in first bracket and comma, then column indexes in the second bracket. Okay, and flatten is basically you just want to convert multi-dimensional array to one-dimensional array, then you will use the flatten. Use of flatten is simply you just want to convert multi-dimensional array to one-dimensional array. There are the lots of things. We need the list for the traditional calculations. When we don't want to do the array operations, then we use the list. For simple data types, we use the list. But when you want to do the operations working over the arrays and big calculations, then you will go with the NumPy. If you want to work with the images also, images is basically inside the Python storing in the form of NumPy array. Okay? Yeah, flatten is for multi-dimensional to one-dimensional. Linspace is creating, basically somebody is asking a question about the linspace. Let me show you. Okay. Linspace is, I just want to generate certain values in between 0 to 10. I want to generate between 0 to 10 3 values. So what I will do, I can start equally spaced. So 10 divided by 3. So difference is 3.33. So first value is 1, then second value is 3.33. And third value is 6.33 something. So equally spaced values you want, this is the start index, okay, and this is the stop index, and this is how many elements you want. Okay, number of elements. And A range is basically I want to generate the 10 values. 10 values. So it will start, it is just like the range function. Okay. So I think this is enough about the NumPy. Let me go ahead towards the pandas. I'll give you the little bit introduction about the pandas. I don't want to go in the deep because in the next class we will cover completely panda. Okay, but today I'll give you overview about the pandas. Okay, so you guys, can you please tell me what is the pandas? What is the use of pandas? Okay, some people know about the pandas. I think most of the people already know about the pandas because this is the famous data Python library for the data analysis. Okay, you want to do some data analysis in the Python, then you should know about the pandas. Okay, So you can say Pandas is fast, powerful, and it is a library for data analysis. You can do the data manipulation. Okay, it is a Python package, and it is most powerful open source package for manipulating the data, available our data. We can, like, whatever, there's some task you can do in the SQL. Okay, what task you can do the SQL? In the SQL, you simply you can join the data, you can filter the data, you can put certain conditions in the data. Similar things we do in the Pandas. We don't need to store the data in any database. We can simply pick the files, and from the file we will read a file, and file having certain data, we can do the analysis of data, of that data in files. We want the people who, top 10 people working in a company, like top 10 highest package person, and we are having the salary data. Okay, we want how many females are working there, how many females are in top 5. We want some filtering, some conditions. We want to do there some data analysis. Then we will use Pandas. Okay, this is the basic definition. There are the lots of things in the Pandas. We have different data types in the Pandas. First thing comes to mind is, what is the Panda? Okay, so I can say data analysis, but more about, I can say it is the data manipulation, okay, analysis, or I can say cleaning also. Okay, and it is generally used for the tabular data. Is best suitable for the tabular data that can be having heterogeneous column type. Okay, data can be unlabeled. There is no label about the data. Okay, we can analyze the data, any statistical data. Okay, so this is about the basic definition about the Pandas. You can do the data manipulation, analysis, and cleaning of the data, and different type of data. You can work with the ordered, unordered, time series data. Okay, and you can have some matrix data. Okay, all these things we can work in the Pandas. And like, if I talk about the certain things that I can do with the Pandas, what type of operation? I'm having certain data. Okay, I can do different operations with the Pandas. Okay, I can say I can do the slicing of the data. Okay, and I can do the merging and joining of data. I can change certain indexes. I can clean data. Okay, these are the operations I can do with the Pandas. There are the lots of other modules also. Pandas is one of the module that we can use for data cleaning. Somebody is asking when we start the machine learning. Guys, this is the part of machine learning. If you don't know these libraries, you cannot work in the machine learning. If you are doing the linear regression, I don't want to go directly in regression. I'll tell you the algorithm, I'll do the implementation, you don't get anything. If you know the libraries, then when I'll do the implementation part, most of the things are already cleared. Like when I'm directly reading data in the machine learning. What is the machine learning? We pick some data, then we do the analysis, cleaning of the data, then we create a model, and then we do some prediction. So first what we are doing here, we are how to read the data from the files, how to do the cleaning of the data, how to do the merging of the data. Then only we can go to the other things. Yes, our NumPy is done. Yes, we are going to use the different use cases in the Pandas. We will make lots of projects in the machine learning. Don't worry about the upcoming things. Tomorrow onwards, I'll close the chat window. Okay? Because people are writing the questions unwanted. If you want to learn the things, then only attend the classes. This is not the mandatory. We are not picking you from your home and giving the classes. It is just some people want to learn the things, so let them learn the things. Yes, it's a temple way. Okay? And this is the Pandas introduction, and now I'll tell you how to do the installation of Pandas. Okay, installation Pandas is similar thing like how to install Pandas. So installing the Pandas, we can write the simple command pip install. It is just like the NumPy. Okay, and there are the different type of data types in the Pandas like 1D, 2D and n-dimensional. So 1D is called series and 2D is called data frame. Data frames, and 3D is called panel. Most frequently we are using data frames. Data frames is very important. Okay. So let me start the column. This column is only dedicated to NumPy. Or shall I start below this? Okay, I'll write here, create a section. Okay, and in this section I'll put Pandas. Okay, and here the first command for installing, some people working in some IDs, you can install pip install Pandas. Okay. So it is already installed. Pip install Pandas. Pandas is already installed in the Google Colab. You don't need to write this command. Now I'll go through the documentation, Pandas documentation, and I'll tell you the things. This is the official site pandas.pydata.org. Okay, and you can go here and getting started. And package overview, if you go to the package overview, you will get the idea. Little bit things are written here like easily handling of missing data, insert and delete, data alignment, we can do the group by, we can easy to convent, we can do the slicing, merging, joining, reshaping, hierarchical labeling, we can analyze the time series. All these things we can work with the flat files, CSV files, Excel files, databases. All these things we can work in the Pandas. So this is the official documentation. Okay, and data structures. Okay, that I told you, data structures, one-dimensional data structure is series. Okay, homogeneously, it have single data type, and data frame is heterogeneous data type. 2D. Okay, so generally we work most over with the data frames, but we should first know the series. Okay, Now come to the GoEdu Hub. Something happened, I don't know, new. GoEdu Hub, and here also good documentation of Pandas. Okay, and this is introduction of Pandas, and this is data frame. Okay, so first I'll go to the introduction of the Pandas because we have covered most of the things. Series, data frame and panel. We don't need to study the panel, data frame would enough. Popular attribute. In the Pandas we are having popular attribute like dtype, empty, size, values, head and 10. Okay, and this is very important. Pandas library is built on top of NumPy. Means when you are working with the Pandas, you should know the NumPy. That's why first I created the NumPy. Okay. So basically we know the NumPy. Now we can start the Pandas. So when you are working with the Pandas, you should know the NumPy. First we will create here import. We just want to use the Pandas, so we need to write this import Pandas as PD. Okay, and we also import NumPy as NP. Now we will declare a array A equals to np dot array in NumPy array. Okay, inside this I'll put an array like G O okay, I declared a NumPy array. Now I just want to convert this NumPy array to Pandas series. Okay, Pandas series is P equals to PD dot series. Series is a function, S should be capital. Series, and inside this I'm passing NumPy array. Okay, and then I'll print P. Okay, and you can see here this is a series, like A is a NumPy array, you know the NumPy array. This NumPy array I have converted to the Pandas series, one dimensional Pandas array, you can say. In the series we have to pass a NumPy array through this series function from the Pandas. PD dot series A, and then you will print the P. You can see GoEdu Hub. Its indexes are 0, 1, 2, 3, 4, 5, 6, 7. So this is the label data. It will convert label data. It is having certain indexes. Indexes are like, by default indexes are from 0 to till the length of the elements. Okay, so basically we are converting a NumPy array to Pandas series. Now you can see the documentation. Here you will get more idea. This is NumPy array. You can see that you know the NumPy array. After that Pandas series, example PD.series, we have seen this example. Okay, we have created a Pandas series with the help of NumPy array. Okay, now clear? Difference between Pandas and NumPy array is NumPy array don't having any index, but the Pandas series having by default indexes along with this. So we can easily read. Okay. Next thing is we can give these indexes by ourselves also. Like these indexes is by default indexes is 0, 1, 2, 3, 4, 5, 6, 7. If we want to change the indexes, we want to put our own indexes. I want the indexes like A, B, C. So I can create a Pandas series with my own indexes. Okay, I can give the indexes, I can see the indexes, lots of things I can do with this Pandas series. Okay. Clear, guys? Like I'm doing the correct things. I don't know people are getting or not, but still I'll go ahead. S1 equals to pd dot series. Okay, and inside I'm creating a random array, random numpy array. How to create a random numpy array? With the help of np dot, there is a package called random, and inside the random there are lots of functions. I'm using only the simple random function, and inside this random function I'm putting 5. It means it will create 5 random values in interval of 0 to 1. In between 0 to 1 it will create the 5 values randomly. This random function inside the random package of NumPy array. Okay, so I'm creating a NumPy array with the random values, and that I'm passing through the series function. So it will convert to the series Pandas series. But here I'm providing one more parameter, that is called the index. Index equals, so I want to give my own indexes. Okay, index equals to, inside the square bracket I want to give my own indexes. I want to give the 5 indexes A, B, C, D. Okay, and now I can print S1, and you can see it generated 5 random values with indexes A, B, C, D, E. And you can see data type is float 64. And previously you can see data type is object. What does it mean? When we are having string kind of things, it's telling you data type is object. When you are having values integer or float, then it will tell you data type is integer or either the float. You can check the type of S1 also. Okay, type of S1, Pandas series, print S1. Okay, Pandas series, and then this. Again, I just want to check the data type inside the series. Then I can write S1 dot D type. So S1 dot D type, data inside this S1 series is float 64. By default it's printing with this series data, but I just want to check out separately, then I can check S1 dot D type. Okay, so I have created a Pandas series with my own indexes. Okay, clear till now? I can create a series from dictionary also. You know the dictionary, in the last class we have studied the dictionary. So data equals to curly braces. I'm creating a dictionary, pi having some value like 3.14, okay, and another key is I'm having e exponent, and exponent having value 2.71, right? We know that we are maths students. And then I can print data, okay. This is one dictionary. Now I just want to convert a dictionary to series. So S3 equals to pd dot series, okay, and inside this I can pass data, okay, and now I can print S3 and you can see the output. How to create a series from NumPy array and from simply from the dictionary also. So if you are creating a series from the dictionary, what happens? Key will become its index and value it's become its value. Now how to access the values? Like we have created a series, how to access series values? Let me create a simple series. This is the simple thing. I'm telling you how to create the series with the help of dictionary. You can create a dictionary and then you can see them. All these things you can see from our documentation also. There all the codes are running. I'm using most of the codes. Okay, so you can read our articles. Reference notes we are providing in description of the video. Okay, let me create s equals to pd dot series, a random series I'll create. Okay, inside this I'm putting np dot random, and inside this I'm putting 5. I'll create a series of 5 random numbers. Okay, then I'll print s. Okay, you can see what is inside the s. This is my s. Okay, I just want to access a particular element. These are the indexes. I can access the elements with the help of the indexes, like s of 1. It will give you the second element, 0.34. S of 0, 0.44. S of 3, 0.012. And same thing, slicing, we can do here slicing, we can access the random elements, we can see the indexes, all these things we can do with the Pandas series also. Okay. Like I want 2 elements, 1 colon 3. So it will give you first index and second index element. 3 is not included. So S of 1 colon 3. It will give you 2 things. Okay. Slicing I can do here. I can get the indexes, only indexes. I want only the indexes. I can get the indexes. Print s dot index. It will give you all the indexes. Range. Start from 0, stop till the 5, step is 1. I can write print s dot ndim. Similar thing to the NumPy, dimension of this, 1 dimension. I can see the s dot size, size of this Pandas series. Total elements, I'm having 5 elements. I can write the shape of this series, s dot shape. Okay, I can use the different functions head and tail. There are the lots of things I can do in this. Okay, so this is the basic introduction about the series. Okay, I think this is enough for today, because if I'll go beyond this, it would be more things for you. Okay, so I can summarize what we have done. Basically, we have tried to cover most of the things in the NumPy, and then we have started the Pandas series and how to create a series, how to access the elements of the series. Okay, all these things we have seen today. Now, till now, I think everything should be clear. You guys can ask me question if you have any question till now. Otherwise, I think this is enough for today. Don't write anything in the chat, guys. Okay, after this ending of the class, you have to put in the comment section. Okay, don't put here anything. Don't do the nonsense things. Again and again, I'm telling the same thing. You guys putting here what we have learned. We have learned this, this, this. These are not the things. Just try to learn the things here. Okay, so these are the things. If you have any question, you can ask me. Otherwise, I'm stopping this lecture. Okay. Okay, and you can see the description of the video after the class. Just see the description of the video. And today I have put it one assignment also, like in the last class we have, till the last class we have seen 2 tasks. Today I have put it one more task, that is the some dictionary exercise practice questions that we have covered in the last class. You have to practice these questions and solve these questions, and after solving these questions, please put to your LinkedIn profile and put the link of this URL, like task link. Okay, and solve these questions. Try to solve these questions, like day after tomorrow you will get the answers below this question also. But first try to solve these questions by yourself. These are the good questions. Like this 5th question is, just try to create 4 functions. With the help of these functions, if user put print, then it will do this task. If user put add, it will do this task. If user put remove, it will do this task, and query, it will do this task. Okay, so try to do these questions. These are the coding questions by yourself. If you are able to do like 3 questions, 4 questions, that is good. Put these 3-4 questions, and after the class I'll before the next class I'll put the solutions, so you guys can cross verify your solutions and you can update your solutions. Okay, so these are the dictionary questions, and I'll also put some task over the NumPy also. So first do this task 3, then I'll put the task 4 also. And same thing you have to do the like LinkedIn question. We will put certain question after the class, need to give the answers, and session summary. Okay, so thank you so much, guys. And next upcoming classes will be more excited. In the next upcoming classes, we are going to do more over the data. We will moving towards the data science, then we will be moving towards the machine learning. So be complete all the previous things, and we also provided one Udemy Python course. So guys, please read the Python course and give the good ratings, reviews, give the 5-star reviews, and also write the detailed description. We are giving so much effort to teaching you guys free of cost, so you can write the good review over the Udemy. Okay, and if you need something else, you can give us the messages through the WhatsApp, and even you can give me some messages in the LinkedIn also. So we try to give you most of the things free of cost, so you guys can give you the good reviews, so that it will increase our profile also. Okay, thank you so much. I think this is enough for today. We will see you tomorrow, and tomorrow's class we will study Pandas data frame. We will do the data analysis over some Excel file. Okay, okay guys. Let me close this.